Hi, hello friends. Welcome to T Academy. In this video, I'm going to provide the power system MCQs, the most common questions, and the questions are collected from the ESC examination, GATE examination, and CL Wadhwa backside bits. Okay, in this video, I'm going to cover 30 questions, and this video series is completely having 100 questions related to power system subject only. Okay, the first question here, the largest size of hydroelectric unit in India. The largest size of hydroelectric unit means each unit is it is having a 165 megawatts. Okay, and the largest size of hydroelectric power plant in India is it is about 2400 megawatts. Okay, so it is Tehri Dam here. And next question, second question here. The hydrograph is similar to. So first of all, what is hydrograph? Hydrograph will indicate the rate of flow or discharge versus time. Okay, so if you take the x-axis and y-axis here, x-axis will be time. Generally, it is in hours, and y-axis is discharge. So discharge is in Q here. Okay. Now it is similar to chronological load curve. Okay, it is similar to chronological load curve. So D is the right answer. Next, move to the third question here. In high head hydroelectric power plant. So please ignore any spelling mistakes or writing mistakes. Okay. In high head hydroelectric power plant, the velocity of water flow in a penstock is around. So it is around 7 meters per second. Okay. And next question here, the fourth one here. The fourth one is the rotameter is used for measuring. The rotameter is used for measuring the fluid discharge. So important question. Those who are preparing for the grammar or Sachivalayam examinations, so this bit is also likely to be asked. Okay. Next one, fifth question here. In thermal power plant, the pressure in the working fluid cycle is developed by. So it is developed by the feed water pump. Okay, so feed water pump is the right answer. Next one, which of the following material cannot be used as a moderator? So the options given are deuterium here, graphite, heavy water, beryllium. The correct answer for this one is deuterium. Okay, so that means we can use these materials, graphite, heavy water, and beryllium, as a moderator, and the material which cannot be used as a moderator is deuterium. Okay, next one, air fuel ratio required for combustion in diesel engine is around. So it is around 15 is to 1 is the right answer for this one. Next one, the energy radiated by sun on a bright sunny day is about dash kilowatt per meter square. The options are 2.5, 1.0, 500 and 200, and the answer for this question is 1.0 kilowatts per meter square. That means the energy radiated from the sun. Okay, next one, there is one numerical problem here. In a 400 kilovolts power network, 360 kV is recorded at 400 kV bus. The reactive power absorbed by shunt reactor rated for 500 MVAR. Okay, 400 kV connected at the bus is dash MVAR. So I will give the hint here, that the hint is the Q, okay, shunt reactor proportional to V square by F here. So here in this question, F is a constant one, so simply we will take, so Q2 by Q1 is equal to V2 by V1 whole square. Just apply this relationship, and you are going to see the answer as T here. Okay, I'm not going to do here. Okay, if you want me, so I will make it another video regarding the numerical problems in power system. So the answer for this question is D here. Okay, for 40.5 MVAR units. Okay. Next one, the salvage value of a plant. The salvage value of a plant may be a positive value, maybe a negative value, maybe a zero value, anything. Okay. So the answer for this for this question is any one of the above here. Okay. So let's move to the next page here. Now next question. The load factor for domestic and industrial loads may be taken approximately as. So approximately the domestic purpose means it is around 10 to 15%, and industrial load means it is going to be 70 to 80% load factor. So what is the load factor? Load factor is nothing but is a ratio of average demand to maximum demand, which is always less than 1. So the answer for this question among the given options, A is the right option here. Okay. Next one, the annual load duration curve. The annual load duration curve of a power supply system may be considered as a straight line from 40 megawatts to 8 megawatts. The load factor of the system is, so the load factor of the system is around 60% here. Okay, you can expect that question. Next one, in an industrial consumer has a load pattern of 200 kilowatts at 0.8 power factor lagging for 12 hours and 100 kilowatts at UPF, the unity power factor, for 12 hours. The load factor, so you know that the load factor is nothing but it's a ratio of average demand by maximum demand. So first of all, energy consumed is how much? So here for 12 hours they are consuming 2000 plus for remaining 12 hours 1000 into 12. Okay, you are getting 3600. Okay, 36,000, sorry, kilowatt hour you are going to get here. Now average demand, what is the formula for average demand? Average demand or average load is nothing but energy consumed in 24 hours divided by time duration. So how much energy consumed here? So energy consumed is 36000 divided by 24. Okay, so you are going to get is 1500 here. I'm just giving the hint here. Okay, I'm not going to solve the problem here. Now this value you get. Now load factor, so load factor is nothing but you know that average value by, okay, maximum demand. So substitute this 1500 divided by the maximum demand of the power plant is 2000. If you solve this, you will get a 0.75. so answer is 0.75 here. Okay, and sorry for the inconvenience, I'm going to explain each and every problem in detail. Okay, so it's just right here. Now 14, the approximate cost ratio of a 220 kV comma underground cable UGC means and 220 kV overhead transmission line is. That means in this question the examiner is asking to compare what is the cost difference between the underground cable and the overhead transmission line for the same voltage rating. Okay, now the approximation cost ratio of underground cable, that means if you are constructing underground cable cost will be equal to 13 to 15 times of overhead transmission line cost. Suppose if you are spending 1 rupee for overhead transmission line, then you have to spend the 13 rupees for construction of underground cable for the same voltage rating. Okay, approximate value. So the answer for this question is C here. Next one, wavy structure of pin insulator increases its dash strength. Okay, the structure of this pin type insulators just like have a just I'm giving a rough diagram here like this. So this is a structure here. So what is going to increase its flash over voltage. So C is the right answer here. Okay, and next one here, 16th question. The string efficiency of a high voltage line is around dash. The string efficiency of a high voltage line, it is around 80%. Okay, so efficiency is 80%, string efficiency, right? Next one, the maximum permissible value of fair weather corona losses for an high voltage line is dash kilowatt per 3-phase kilometers. The maximum permissible value of a fair weather corona losses for an HV line is dash kilowatt per 3-phase per kilometer. So the options are 0.6, 1.2, 0.3, 2.4. The correct answer is 2.4, okay, kilowatts per 3-phase kilometers. Next one, for 11 kV line, the inductance per kilometer per phase will be a order of dash. That means if you take a 11 kV line, the inductance per kilometer, that means if you take a length of 1 kilometer line, transmission line, what will be its inductance value? Okay, so these questions are typical questions, okay, which are practically have some values. Okay, so in this question, the answer for these questions are 1 Henry, 0.1 Henry, and C as 1 millihenry, D as 0.1 millihenry. The correct answer for this question is C, 1 millihenry is the right answer. Next one, the self GMD, or we can also call it as a GMR, of a conductor with a 3 strands each of radius r, okay, and touching each other. That means there are 3 strands are there. Okay, they're touching each other means, so here, okay, not this one. So this is a configuration like this. Now what is the GMR value? So GMR is meant r is the radius of each conductor into 0.7788 into 2 into 2 into to the power of 1 by 3 here. Okay, so this is the right answer for this question here. So this type of questions are especially asked in PSU exams for A's. Okay, next one, in a HP transmission, spacing between the subconductors of a bundle is approximately dash meters. Okay, in a high voltage transmission line means more than 220 kV. Spacing between the subconductors of a bundle conductor. Suppose you take a conductor here, bundle conductor means here we have like this bundle conductors are there. So there will be another bundle conductors here going in the line. Okay, like this. Now what is the distance between the subconductors of a bundled conductor is dash meters. Actually here will be centimeters, dash centimeters, not meters. The answer for this question is, it is 40. Okay, so 40 meters here, 40 meters. So next question here, for a stranded conductor, the ratio of GMR to the actual radius is, the ratio of r dash is equal to 0.7788 r value here. Okay, the ratio of GMR to the actual radius will be, it is less than 0.7788. okay, so actual ratio, okay, not theoretically you can say it as a r dash equal to 0.7788 r, but practically it is less than that value. Next one, 22nd question, the installation of modern EHV lines designed based on, so normally the installation is depends upon voltages, okay, the voltages, but here the installation of modern extra high voltage lines is designed based on the switching voltages. So answer is D here. Okay, it is not on corona, it is not on lightning, it is not on radio interference. Next one, 23rd question here, a single phase transmission line having an impedance of Z is equal to 0.8 ohm supplies a resistive lagging load of 500 amperes at 300 volts. The sending end power factor. So to find the sending end power factor, Vs is equal to, so Vr plus IXL. So if you take here, Vr is how much? 300 plus current is 500 into J 0.8. Okay, if you are going to solve this, you will get a 300 plus J 400. Now how to find the power factor? So cos phi is nothing but, it is simply, you can consider the formula R by Z, actual real value by total impedance value. Okay, so here R is 300 divided by Z value is 300 square plus 400 square whole square root means now you will get it as a 300 square plus 400 square root of, if you solve this, you will get a 300 by 500. So 3 by 5 means the answer is going to be 0.6 here approximately. Okay, next one. For a transmission line with a R and X, R is nothing but resistance, X is nothing but reactance, and negligible C for capacitance, then the generator constant A is dash. What is generator constant A? So generator constant A is nothing but A is equal to Vs, sorry, uh, Vr is equal to A into Vs plus B into IR here. Okay. Now if you take the IR as a 0, then A is equal to Vs by Vr. Okay, for a transmission line, it is approximately made equal to 1 here. So answer is 1. Next one. The collapsing in a transmission line conductor arises generally due to, so the collapsing means vibration of the conductors. It is due to, the options are asymmetrical layers of ice formation, the vortex phenomena in light winds, heavy weight of the line conductors, and adoption of horizontal configuration. So answer for this question is adoption of horizontal conductor configuration. Next question here. The charging reactance of 50 km length of line is 1500 ohms. What is the charging reactance for 100 km length of the line? Generally remember the formula here, concept here. The Xc, that is the reactance, is inversely proportional to length here. Just apply the relationship for this question and you may get the answer as 750. Okay, 750 ohms. Well, because as the length increases, automatically the reactance will decrease here. So length increases by half, reactance decreases by half here. So 1500 by 2 means 750 will get. Next one. What is the approximate breakdown strength of atmosphere air at NTP? Okay, the options are 0.3 kilovolts per centimeter, B is 1.0 per centimeter, and C is 3 kV per centimeter, and D is 30 kilovolts per centimeter. So answer is 30 kilovolts per centimeter. Next one. The number of discs in a string of insulators for 400 kV AC overhead transmission line is. Okay, so the value which you are given are of line voltages. So convert into phase voltage, and you are going to see that for a 400 kV line, you will get it as 22 to 23. Actually it requires 22 plus, because of factor of safety you will add one more here, so it's going to be 23rd here. Okay, next one. Whenever the conductor or dead ends, or there is a change in direction of transmission line, the insulator used are dash type. I repeat the question. Whenever the conductors are dead end or there is a change in the direction of the transmission line, the insulators are used and dash type of. So they are going to use, the options are pin type, suspension type, strain type, shackle type. The correct answer for this question is, it is strain type. And the last question for this session is, two insulator discs of identical capacitance value C make up a string of 22 kV 50 Hz single phase transmission overhead transmission line. If the pin 2 at the capacitance is also C, then the string efficiency is, defined as the total voltage across the string, that is the two discs are there, divided by number of discs 2 into the voltage across the string nearer to the conductor is V2 here. So from this relationship, V2 is equal to, we know that 1 plus M into V1. Okay, so in the given problem, M is nothing but it's a mutual capacitance to stray capacitance. It is given as C by C is going to be 1. So from this, V2 is equal to how much? V2 is equal to 2 times that of V1. Just substitute here efficiency value. You may found that, so V1 plus V2 means 3 V1 divided by, so 2 into 2 means it is going to be 4 V1. If efficiency means 100 means, if you consider here, it is 75%. So the answer for this question is, that is the 30th question, is B here. Okay, so that's it friends, that's it for this session. If you like this video, please subscribe to our channel and share with your friends. Thank you, have a nice day. And one more thing, I will make the same video. If you are interested, I will make it in Hindi also, right? Thank you. Hi, hello friends, welcome to T Academy. Let's continue the power system MCQs. The questions are from the ASC, GATE and PSU examinations and CL Wadhwa backside bits here. Okay, so in my previous video of this series, I had given 30 questions and I discussed the answers for that questions, and let's continue the remaining 30 questions to 60 questions in this video, and the remaining question will be in the part 3. So this is the second part of this power system MCQs. Okay, so let's continue the series of questions here. Okay, now the first question here on the screen is, the load frequency control is achieved by properly matching the individual machines. Friends, one more request here, so please ignore the spellings mistakes. Okay, load frequency control is achieved by properly matching the individual machines. So it is going to be by matching, the options are reactive power, the generated voltage, turbine inputs, turbine and generator ratings. So the answer here is, it is matching the turbine inputs here. Okay, load frequency. Why? Because they are going to control the speed. As you know, the relationship here, ns is equal to 120 f by p. Okay, so C is the right answer for this question. Next question here, as you can see, the load frequency controllers are carried out with a dash controller. That means in a power system, you need to, in order to control the load frequency, that means in order to control the speed, which type of controllers we are adopting here? The answer for this, proportional integral derivative. That is, the answer is D here. Okay, so P for proportional, I for integral and D for derivative, but the answer here it is PID. Next one, 33rd question. A plant has a maximum demand of 15 megawatts. Okay, numerical problem. The load factor is about 50% and the plant capacity factor is about 40%. What is the reserve dash? So here I will just give a hint for this question. I am not going to discuss in detail about the solutions here. I will just give the hint for this question here. Okay, now here, what is the load factor? So load factor is nothing but its ratio of average demand by maximum demand. So in the given data, maximum demand is given, load factor is given. Okay, so from this what you can find is, you can find easily the average demand. So how much average demand you will get? So average demand from this you will get it as, so AD is equal to 7.5 megawatts, you will get it. Okay, so it is in the option, but what they asked to find the reserve capacity. So reserve capacity or reserve is nothing but installed capacity minus maximum demand. So in order to find the installed capacity, what's the formula here we have? So installed capacity is equal to average demand by plant capacity factor. So plant capacity factor I'm saying. So average demand, you know, 7.5 divided by plant capacity factor is how much? Okay, it is 40%, 0.4. So 7.5 divided by 0.4, you will get it as 75 by 4. Now just substitute the IC value, MD value. So what will you get? 75 minus 4, 75 divided by 4 minus maximum demand is how much? It is 15. So if you solve this, you will get the answer as 3.75. So answer for this question is, it is 3.75. So hope you will understand the question here. Okay, so try to solve on your own, you will get the answer. Okay, next question here. The economics of power plant is greatly influenced by economic aspects of power system. In the economic aspects of power system, we study about the load factor, utilization factor, unit capacity and type of load. So The economics can be affected by all these four factors here, that is load factor, utilization factor, unit capacity and type of load. So answer for the 34th question is, it is A here. Okay, next one. The incremental cost characteristics of a two generators delivers 200 megawatts. Now the given as dfn by dp1 is equal to make it correction here 2.0 here friends, 2.0 plus 0.01 p1 plus df2 by dp2 is equal to 1.6 plus 0.02 p2. Okay, so for economic operation, what is the p1 and p2 values? So I will give the hint here. First is, let us consider the p1 plus p2. You will get it as how much? It is 200. Okay, now take df1 by dp1 is equal to df2 by dp2. So do it. Okay, note it down. df1 by dp1 is equal to df2 by dp2, that is equal to 2.0 plus 0.01 p1, which is equal to 1.6 plus 0.02. I'm repeating, 2.0 plus 0.01 p1, okay, written, which is equal to 1.6 plus 0.02. So if you equal this, then you will get an equation in terms of p1 and p2. Just add these two equations, you will get the p1 and p2 values, and the answer options are 100 and 100, 80 and 120, 200 and 100, 120 and 80. So if p1 plus p2 are 200, A option may be correct, B option is correct, but C may not be option. Why? Because total load is 300, but the given data is 200 only. So this will not be the answer. You can directly see that question options. You can eliminate the answer, and if you found the answer, so P1 and P2 will be, so P1 is going to be 120 and the P2 is going to be 80 megawatts here. Okay, next one. Now next we'll go for the 36th question here. In order to have low cost of power generation, load factor and diversity factors. Okay, LF means load factor here, DF means diversity factor. I have written here. So load factor and diversity factor, how it should be. So as we know that the diversity factor is greater than 1 and the load factor is always less than 1, but in order to have low cost, these two should be high values. Okay, so the load factor and the diversity factor should be high values. The other options are load factor, diversity factor low, load factor should be high, diversity factor should be low, load factor should be low, or diversity factor should be high. Okay, and next question. For a 15 bus power system with a 3 voltage controlled bus, the size of the Jacobian matrix is. It's a very important, friends, because most of the examinations they will focus on this type of question only. So the answer for this question is 2n minus m minus 2. So what else are n's are here? N is nothing but total number of buses. So this value is n and this value is going to be m. Just substitute here. So 2 into 15, 30. 13 minus 3, how much? 30 minus 3, 27. 27 minus 2 is 25. So size of the Jacobian matrix will be, so 2n minus m minus 2. So answer here is D. Okay, D is the right answer. Next one. Next question. So this is also important one from the load flow studies. The Y bus matrix of a 100 bus interconnected system with a 90% sparse. Hence the number of transmission lines in the system must be. Okay, so in the system must be. So I will directly tell the formula without going to the concept here. The number of transmission lines will be equal to n square into 1 minus x minus n divided by 2 here. So what is the n? So I'll just tell here, n is nothing but how much? 100. So substitute n as 100 and x value as 0.9. So everything will be, so you will get it as 900 by 2. So answer is 450. So the A option matches with the answer here. Okay, so the answer is A is the right option here. Next one. The load flow studies involves solving the simultaneous dash equations. So I'm repeating the question here again. The load flow studies involve solving simultaneous dash equations. So they are linear algebraic, non-linear algebraic, linear differential, non-linear differential. The load flow studies equations involves the non-linear algebraic equations. Okay, if you take any voltage or current values, you will see the sigma notation. Sigma is equal to 1 to n y p k, like that the formula is there. Okay, if you study the node flow studies by using node and absent method or Gauss-Seidel method, you will observe the equations here. Okay, so this question is also asked in a previous transco paper. Okay, next one. Normally Z bus matrix is a dash matrix. So there are two questions are there from this. What is Y bus matrix? What is Z bus matrix? So Z bus matrix is always it is a full matrix. If they ask about what is a Y bus matrix, so Y bus matrix is always a sparse matrix. Sparse matrix. Sparse matrix means most of the elements are zero elements. Okay. Now, so before going to the next slide, if you like this video, please subscribe to our channel and share with your friends, and make a comment, okay, whether you like this video or not. Okay, if you want any other changes, we will provide you. Okay, and we'll start the next slide here. The bus admittance matrix of the network shown here. So here there is a network here, as you can observe. In that network, we need to find the value of y11, y12, y21. Okay, so first let me take here the matrix here. First of all, y11. So capital y11, if you take, there are the two nodes connected here, so they are in impedances. So 1 by j 0.2 plus 1 by j 0.2, so you will get it as minus j10 directly. Okay, and similarly y12, so y12 is equal to y21 is equal to 1 by j 0.2 is nothing but, yes, it is minus j 0.5. and similarly y22, only one element is connected, so 1 by j 0.2 is nothing but 0.5j minus. But in the given options, observe here, that is here the whatever the value is there, that value is y12 is equal to minus of y12. So based on that concept, y11 will be minus j10, so option is C is matching. And y12 here second value will be minus of this value, so here plus value, no, make correction here, it's a 5 here. Okay, it's not 0.5, it's a 5, so 5 will get it here, and y12 as it is. So based on these options here, the correct answer is C here. Next one. At slack bus, which of the following combinations of the variables are specified at a slack bus? So slack bus means the specified variables are voltage, magnitude, and the phase angle, the load angle delta here. Okay, and given options are V comma delta, P that is active power, Q is the reactive power. P is nothing but active power, V is the voltage, and Q is the reactive power, V is the voltage. So among the options, A is the right option here. Next one. A 10-kilometer long lossless transmission line has a reactance of 0.3 ohms per kilometer. Okay, they given a reactance here. Okay, and negligible shunt capacitance. That means if they say negligible shunt capacitance, means you can say it as a STL, that is short transmission line, and the value of ABCDs. Already we studied that A value will be 1. So among the options you can see, you can eliminate the D option. Why? Because A is always 1. B is nothing but having units of ohms. Okay, ohms per length here, but the given 0.3 ohm per kilometer, how many kilometers? 10 kilometers. So 0.3 into 10, how much? 3. So option is J3, and A is equal to D, it follows. Okay, and finally C value will be 0 because negligible capacitance means C value always 0. So you can eliminate these two options. Why? Because as you see, C is negligible. So among the options directly without solving any data, you can see C is the right option here. Next one, which of the following sets of three-phase transformer connection with the zero sequence currents be absent in the transformer windings? Okay, so in order to flow the zero sequence currents, there should be a grounding. Okay, so grounding is possible only in case of star connection. Okay, special case delta with tertiary winding. But here in the given options, only the given star and delta. The first one is for primary is a star with the ground, and secondary is only star. Primary is star with the grounding here, and secondary is delta. Primary with the star, secondary is star with grounding, and the last option is primary is a star, secondary is delta here. Okay, so among these following connections, D is the right option. Why? Because if there is no grounding in the star connection, so the currents will not flow. Delta, okay, obviously no grounding means it will not flow here. So except this option, all other options having a ground connections, so you can eliminate this. Next one, when a LG fault occurs, the current in faulted phase is 100 amperes. The zero sequence current will be, okay, when a LG fault occurs, the current in the faulted phase is 100 amperes. Okay, 100 amperes current is given. So how much they given? Fault current is 100 amperes. The zero sequence current will be, okay, remember the relationship, fault current in any ground fault, it is 3 times that of I naught here. So based on this, okay, the zero sequence current I naught is equal to the fault current divided by 3, which is nothing but 100 by 3 amperes. So 100 by 3 means 33.3 amperes is the correct option here. Next one, the per unit impedance of a synchronous machine is 0.242 per unit values. If the base voltage is increased by 1.1 times, the per unit value will be, okay, so the per unit impedance of a synchronous machine is 0.242. If the PB is increased by 1.1 times, the per unit value will be, okay, so the answer is simple here. The per unit impedance of synchronous machine is Z per unit is equal to, okay, so Z volt into MVA volt divided by MVA new into VB old whole square divided by VB new square. I'll write the formula. Z per unit new is equal to Z naught old value into MVA new divided by MVA old into VB naught square by VB old square divided by VB new square. Okay, sir. So here they are asking new per unit value. Z per unit new is equal to Z naught value 0.242, right here 0.242, I'll write it down. So into MVA is same, so they're going to cancel. So into 1 divided by 1.1 whole square. If you solve this, you will get the answer as D as 0.2. Okay. So we'll move to the next question here. Okay, right. If the positive, negative, zero sequence reactances of an element of a system are 0.3, 0.3, 0.9 respectively, then the system element will be A. So generally see here in a synchronous generator, synchronous motor, static load. Okay, so almost all Z1 is equal to Z2 is equal to Z0 generally. Okay, I'm not, but in a transmission line only, the Z0 will be more compared to Z2, and Z2 and Z1 will be equal. Remember the relationship here. This is a very important one. Based on this concept, they asked one question in examination. Okay, so the answer is D is the transmission lines here. Four alternators, I'm repeating, 4 alternators, each rated 5 MVA 11 kV with 20% reactances working in parallel. The short circuit level will be, So short circuit MVA, the formula is, it is going to be MVA base by X per unit. So when the four alternates are operating parallel, so X per unit value will be, so 20% by 4, it is going to be 5%. Just substitute here X per unit as a 5%, and the MVA base is 5. So 5 MVA divided by 5% means 5 by 100. So simply we'll get as what? 100 MVA. Answer is 100. Next one. A three-phase transformer having a zero sequence impedance Z0 has the zero sequence network shown here. This is zero sequence network here. As you can see, zero sequence network is there. In the zero sequence network, the connections of this winding will be, so if you see here, there is a connection here, switching connection here. This is a star grounded with a delta, star grounded with delta. So the options star grounded with delta is the correct option here. Next one, 50th question here. A 4 kVA 400 watt 200 single phase transformer has a resistance as 0.02 per unit and X is equal to 0.06 per unit. Its actual resistance and reactance refer to the HP side of the transformer are respectively in dash ohms here. Okay, so first what we will do is we will find the base values here. Okay, so to find the base value, let me consider RB. RB is equal to XB. Both are base values only. XB is equal to, so V base square divided by S base. So what is the V base square? So V base is how much? Voltage base level of HV reference side means 400 into 400 divided by S base is 4000. How much you will get here? It is 40. Just multiply here. Now X value and R value you want. So X new value or X actual value, X actual is equal to, it is X per unit into, okay, X base. So how much here? X per unit is 0.06 into 40. Okay, similarly R actual value is equal to R per unit into R base, 0.02 into 40. Now we'll get the answer. So just solve this to, simply you'll get the answer it as B. Okay, so B is the right option here. Next one, the fault calculations using computer program are usually done by, so it is generally fault calculations will require more memory space if you use a Z bus. So by using the Y bus matrix, you can reduce that memory requirement of the computers. So Y bus is preferred in fault calculations. Okay, and Z bus is preferred in load flow studies. Next one, the zero sequence current of a generator for a LG fault is J 2.4 per unit. Then the current through the neutral during the fault is, repeat the question here, the zero sequence currents of a generator for a LG fault is J 2.4 per unit. The current through the neutral during the fault is, okay, the current during the fault during the in the neutral is going to be, so it is 3 times that of I. Okay, so I not here. Okay, so that is going to be 3 into I naught means J 2.4, it is nothing but J 7.2. so answer you C is the right option, and the option A is 2.4, B is 0.8 and C is 0.24. And the next question, the line currents of a three-phase supply are IR is equal to J3 plus J5, IY is equal to 2 plus J2, and IB is equal to minus 2 minus JA, the zero sequence current will be, okay, I'll write the formula here. Zero sequence current I naught is equal to 1 by 3 times that of IR plus IY plus IB. So add these three currents and divided by 3, you'll get the answer as 1 plus J2. So A is the right answer here. Next one. If all sequence voltages at the fault point in a system are equal, okay, and they are not zero, they are equal, then the fault is, okay, so what type of fault it is? If they are equal, then the fault is going to be, the options are three phase faults, LG fault, LL fault, double L to ground fault here. So answer is double L to ground fault. If all the sequence voltage at the fault point in the system are same, they are in parallel. Next one. The per unit value of a 4 ohm resistor at 100 MVA base and 10 kVA base voltage is going to be dash. So the first we need to find R per unit is equal to, okay, so what is the per unit value of R? Actually it is a 4. What is the base value? So we need to find the base value. So actual value of base value. So base value means VB square divided by MVA. So here MVA is 100, VB square is how much here? VB 10 whole square. So what you'll get here is 4 into 100 divided by 10 square. So you'll get it as a 4. Answer is B here. So one more request friends, please watch this video in the YouTube, okay, so that this video will be getting good views, okay. If you are simply downloading and watching, the channel will not grow and the videos also not going to be help to others, okay. Next question. The transient stability limit of a power system can be approximately increased by, appreciably increased by introducing. The transient stability or limit of a power system on a power system can be appreciably increased by introducing series capacitor is the right answer, and the other options are series inductance, shunt capacitance. Okay, so how the series capacitors will improve is it is going to decrease the net transmission line reactance. Okay, if the transmission line reactance is less, the transient stability automatically will be improved here. Okay, and also it will provide the reactive power support to the transmission line. Next one. A power system network with a capacity of 100 MVA has a source impedance of 10% at a point. The fault level at that point will be dash MVA. So already given the formula here, short circuit MVA is nothing but is equal to, so base MVA divided by X per unit. So here the MVA is, base MVA is 100 divided by 10% means 10 divided by 100, it is going to be 1000. So 1000 is the right option. The other options are 10, 30 and 3000 here. Next one. Shunt compensation in EHV line is used to. The shunt compensation in EHV line is used. The options are improve stability, reduce the fault level, improve the voltage profile, and last option is substitute for the synchronous phase modifier. The correct option is C is the correct option. And next one, the equal area criteria. So equal area criteria given the information regarding, so equal area criteria will give the information regarding the stability region, absolute stability, relative stability, swing curves. The correct option for this question is it is going to provide the stability regions are there. And the last question for this session is the critical clearing time of a fault in a power system is related to dash limit. The critical clearing time TC at a fault point in a power system is related to dash limit. So it is going to tell you about the options are reactive power, short circuit, steady state stability, transient stability. The answer is for this question is it's going to tell about the transient stability limit. So thank you friends, thanks for watching my video. If you like this video, please subscribe to our channel and share with your friends. Thank you. Hi, hello friends, welcome to T Academy. This video is a third part of the power system most common questions, and the questions are collected from the previous ESE questions, GATE questions and PSU, and the backside bits of CL Volvo textbook. Okay, so if you go through these three videos, okay, before the examination, I can assure you that at least you can expect 5 questions from these 100 questions. Okay, if you are go through with this 100 questions thoroughly, you can attempt 5 questions minimum, I'm saying. Okay, and don't expect these questions will be repeated in GATE exam. So GATE is a higher level exam, but I'm saying the same questions will be appear for you in the examination of PSU or ESE. Okay, don't expect the same questions in GATE examination. It's a foolishness. Okay, so I can assure you that go through these videos, okay, and try to solve the problems. I given almost all the hints. Okay, nearer to the answer I given a hint, so that try to solve these papers and watch this video through online only, so that the channel will improve. Okay, so the channel will improve means automatically I can make the videos in other languages also. Okay, so please subscribe those who are new to our channel, and if you like this video, please like the hit button. Okay, now we'll continue the last part, and we're going to cover the questions from the 60 question to 100. Okay, so in this video we're going to cover the 40 questions which are numerical as well as theoretical concepts. So let's start the question here. An infinite bus of 1 per unit is fed from a synchronous machine having E is equal to 1.1 per unit. If the transfer reactance between them is 0.5 per unit, the steady state power limit will be dash per unit. Okay, so the question here so simple. An infinite bus bar is there, okay, which having a 1 per unit is fed from a synchronous machine. 1 per unit may be a power or voltage given, and synchronous machines having a E is equal to, that is the EMF induced is 1.1 per unit. Okay, that means the voltage they given. The transfer reactance between them is 0.4, okay, 0.5 per unit. The steady state power limit, so PSS is equal to EV by X. E is 1.1, V is 1 divided by 0.5. Simply you can say 2.2. The options are 1.1, 0.5, 2.2, 1. So answer is 2.2. And the next question here. The inertia constant of 100 MVA 50 Hz 4-pole generator is 10 megajoules per MVA. If the mechanical input to the machine is suddenly raised from 50 to 75 megawatts, then the rotor acceleration will be equal to dash electrical degree per second square. Okay, I will repeat the question. The inertia constant of a 100 MVA 50 Hz 4-pole generator is 10 megajoules per MVA. If the mechanical input to the machine is suddenly raised from 50 to 75 megawatts, then the rotor acceleration will be equal to so the answer for this question I will give you directly. Okay, explanation I will give in the next upcoming videos. Okay, it will take some time. So answer is 225 electrical degrees per second square. Okay, next question. If a generator of 250 MVA rating has an inertia constant of 6 megajoules per MVA, its inertia constant on 100 MVA base will be. So here inertia constant H is inversely proportional to the rating of the generator. Use this relationship H2 by H1 is equal to G1 by G2. So from this H2 is equal to, so G1, okay, so G1 value is how much? It is the given as a 250 divided by next rating is 100 into 6. Okay, so we'll get the answer as 15. Okay, and the next question here. Let me correct here, right? Okay, right. Next question. For 800 megajoule stored energy in the rotor of a rotor at synchronous speed. What is the inertia constant H for a 50 Hz 4-pole turbo generator rated 100 MVA 11 kV dash? Repeat the question. For a 800 megajoules stored energy in a rotor at a synchronous speed, what is the inertia constant H for a 50 Hz 4-pole turbo generator rated 100 MVA 11 kV is? So H is nothing but the inertia constant nothing but energy stored divided by the rating of the machine. So what is energy stored? It is 800 megajoules per. What is the rated here? 100. So simply 800 by 100 means 800 by 100 means you will get the answer. It has S 8 megajoules per MVA. So other options also 2 they given, 4 they given, 6 they given. Correct option is 8 here. Next one. The steady state limit for a round rotor and a silent pole 3-phase synchronous generator are attained at the values of the power angle delta and dash respectively. The steady state limit for the round rotor and the silent pole 3-phase synchronous generator are attained. So they are going to attain the values. Okay. Steady state limit maximum value is going to be D is the most appropriate answer. It is equal to 90 for for a round rotor, and for a silent pole machine it is less than 90 degrees. Next one. The inertia constant H is equal to M 8 megajoules per MVA. For a 500 MVA generator, the energy stored is, so simply H is given as 8, energy stored in megajoules, energy stored divided by MVA rating G here. So energy stored in joules, okay, energy is equal to H into 50. So how much is nothing but 400. So C is the right answer, and the other options are 500, 8 and 6.25. A 3-phase circuit breaker is rated at 2000 MVA 33 kV. The making current will be dash kiloamperes. So the making current, IM is equal to 2.55 into, okay, so 2.55 into the MVA rating is 2000 divided by root 3 into the actual voltage is 33. Okay, we will substitute here, we'll get the answer as 89 kiloamperes. The other options are 35, 70, 16. Next one. In a merge price percentage differential protection of a delta star transformer, the CT secondary connection in the primary and secondary windings of the transformer would be in the form of, if the primary is a delta, okay, that CT connection will be star. If it's a secondary is a star delta, just make it opposite. Okay, so why they are making? Because of 30 degrees phase displacement. So for the 68 question, B is the right answer. The other options are delta star, delta star star here. Next one, 69th question here. In a 200 kV, L is equal to 25 millihenry, C is equal to 0.025 microfarads. The value of the resistor required to be connected across the breaker contacts, which will give no transient oscillations, is, so which will not give no translation oscillations means, so R is equal to 0.5 into square root of L by C is the right answer. So L is nothing but 25 million, substitute here, and C value 0.025 microfarads. If you are substituting here, so simply you will get the answer. Okay, and the option was 25, 250, 500,000. The answer is 500 here. Next one, the rate of rise of restacking voltage is depends upon, so it's going to depends upon R, L, C and the L and C. The option is L and C is the right option. Next one, which of the following grounding methods is used to reduce the tower footing resistance when the earth resistance is low? Okay, it is this single driven rod. Next one, The impulse ratio of insulators and lighting arresters should be dash respectively. So they should be, the impulse ratio should be high and the lighting arrestor should have a low value. So the options are both low, high and low, low and high, both high. So the correct option is impulse ratio of the insulator should be high, the lighting arrestor should be low. So for this, correct option is B. Next one. If a fault current is 2 kA, the relay setting is 50% and the CT ratio is 400 by 5, then the plug setting multiplier of the relay will be. So the PSM plug setting multiplier of the relay will be, that's nothing but fault current divided by CT current setting into CT ratio. CT current setting is how much? 50%. So 50% means 50 by 100 into 5 into CT ratio is 400 by 5. So fault current is 2000. Substitute all these values, you'll get the answer as, the options are 5, 7, 8, 10. The correct option is D here. Next one, the relay which has the capability to anticipating the possible major fault in transformer. Okay, the answer options are overcurrent, differential relay, Volcus relay, overfluxing relay. So the answer is Volcus relay has the capability to anticipate the fault. Okay, it's a very important question. The figure shown represents operating characteristics of dash relay. So see here there is a operating region inside the circle and a non-operating zone outside the circle here. Okay, the correct answer for this question is, the options are reactance, directional impedance, more relay. The answer is more relay. Next one, how many relays are used to detect the interface faults of a 3-line system? Okay, so how many relays are used to detect interface faults of a 3-line system? So 3-line system will be, options are 1, 2, 3, 6. The correct option is 3 is the right option. Next one, what's the preferred type of circuit breaker to be installed on extra HVAC system? So EHVAC system. So which type of circuit breaker you're going to prefer? You're going to prefer, okay, the SF6 circuit breakers. SF6 circuit breakers. SF6 circuit breakers. So bulk coil circuit breaker, air blast circuit breaker, vacuum circuit breakers are the other options. The correct option is SF6 circuit breakers. Right. Next one. The more relay is usually employed for the protection of dash lines. Okay, the options are short, medium, long, anyone. The option is more relay. It is used for the protection of long transmission lines. So E and B are the wrong options. Next one, under voltage relays are mainly used for dash protection. So the options are motor, transformer, transmission line, and none. The correct answer for this question is A, motor. Next one, fiber optic cables are used in the power system applications mainly for, okay, so it is mainly used for SCADA system, communication between the power system and substation, communication between the power system and load control centers. Okay, load control center, D, all of the above. I will repeat the options here. SCADA, communication between the power system and substation, communication between the power system and load control center, and D is all. So the correct option is D is the right option here. Next one, the surge impedance of a 50 kilometer long underground cable, UGC means underground cable, is 50 mega ohms. For a 25 kilometers length will be dash mega ohms. So remember, it's very important, simple question here. It is saying that the surge impedance. So surge impedance loading or surge impedance is independent of length. Independent of length. So it does not depend upon length. The options are 25, 50, 100, 786. Okay, so when you say it is a 50 mega ohms, it will remain 50 mega ohms only. The answer is B. Next one, the positive sequence, negative sequence, and zero sequence of a solidly grounded system under the steady state condition always follow the relationship. So here the positive negative sequence of a solidly grounded system. So solidly grounded system, the relationship is where Z1 and Z2, Z1 is greater than Z2, Z1 greater than Z2 greater than Z0. So Z0 will be least way because it is a solidly grounded system. So correct options is A here. Next one, The current carrier current protection scheme is normally used for. The carrier current protection scheme is generally used for. The options are HV transmission lines, HV cables, both and none. Okay, so for the 83rd question, it is used for high voltage transmission lines. Next one, 84th, the ratio of reset to pickup, the ratio of reset to pickup current for an induction relay is approximately, okay, it is, the options are 0.99, 1.01, 0.75, none. So it is approximately equal to 1 but not greater than 1. Next one, the rotation of the disc of an induction disc relay under the pole is, the options are from unshaded pole to shaded pole to unshaded pole, depends upon current, all of the above. So for the 85th question, it is the rotation of the disc of the induction disc relay under the pole is from unshaded pole to shaded pole, from unshaded pole to shaded pole here. Next one, the shape of the disc of an induction disc relay is, the shape of the disc of an induction disc relay is, so it is spiral. The other options are circular, elliptical, square. Next one, the most economic load on a underground cable is, so underground cable is the most economical load. The options are greater than its surge impedance loading, less than its surge impedance loading, equal to surge loading, and D none. So the option for this is less than its surge impedance, surge loading here. So answer is B here. Next one, for the same rupturing capacity, the actual current, for the same rupturing capacity, the actual current to be interrupted by a HRC fuse is, okay, it is much lesser than any CB, much more than CB. So here CB means not chicken biryani, it is circuit breaker. So C is nothing, C here equal to CB and D is none. So option is A. Next one, the capacitor switching is easily done with, with the help of dash. The options are air blast circuit breaker, oil circuit breaker, vacuum circuit breaker, any one. So the correct option here it is vacuum circuit breakers. Next one, the current chopping tendency is minimized by using dash, using the SF6 gas at a relatively dash pressure and dash velocity. I'll repeat the question. The current chopping tendency is minimized by using the SF6 gas at a dash pressure, okay, and dash velocity. The options are high and low, high and high, low and low, and low and high. So the correct option here it is low and low pressure and low velocity. Okay, so check the above question. Next one, if fault is more severe from the viewpoint of RRRV, okay, that is the rate of rise of restacking voltage. If it is a dash fault, so it is, the options are short, medium, long, and none. So the option is A is the right. The fault is a more severe from the viewpoint of restacking voltage, rate of rise of restacking voltage, if it is a short circuit fault. Next one, an overhead transmission line, the series compensation is protected by using dash relay. Okay, so the options are impedance, reactance, Mo, and D none. Okay, for the this question, the answer is it is impedance relay. An overhead transmission line with a series compensation can be protected by using impedance relay. The typical value of SCR, not SCR means it is not a semi-controlled rectifier, it is short circuit ratio for a modern alternator is about. So the generally the SCR is 0.5 is the right answer. The other options are 1.5, 1.0. Why? Because the SCR is inversely proportional to 1 by the reactance. So normally the reactance are maintaining at 2 per unit in a modern alternators. Okay, so 1 by 2 is nothing but 0.5. For a lumped inductive load which increases in supply frequency. Okay, so in a lumped inductive load with increase in supply frequency, the P and the Q increases, P increases, Q decreases, P decreases, and Q increases. So P and Q. So P means active and reactive powers. So for a lumped inductive load with the increase in supply frequency, so what is going to increase? It is the active power decreases, reactive power will increases. Next one, the gas turbines can be brought to the bus bar from cold is about. So how much time? So gas turbines, it will take around how many hours here? So options are 2 minutes not possible, 30 minutes not possible, 1 hour not possible. At least it will take 2 hours of time to get started. Suppose if it is a thermal power plant, so thermal power plant means it will take 8 hours to get started. Now next one, the phase modifier is normally installed in case of dash lines. The phase modifier is normally installed in case of dash lines. The options are short, medium, long. Okay, so phase modifiers are installed in case of when the transmission line is a long transmission line. Next one, the series compensation on EHV lines is restored to. The series compensation on EHV lines is restored to. So improve stability, reduce the fault level, improve the voltage profile, TR. So series compensation which we are going to use to improve the stability. Okay. Next one, stringing chart is used for. The stringing chart is used for. The options are finding sag in conductors, design of towers, design of insulators, all. So the stringing chart is useful in finding the sag in the conductors. And next one, the voltage controlled bus is treated as a load bus in the subsequent iteration when it is dash limit is violated. So very important question. A voltage controlled bus is treated as a load bus in a subsequent iteration when its dash limit is violated. The options are voltage, active power, reactive power, phase angle. So the option here is the reactive power. So reactive power. So reactive power. C is the right option. And the last question for this session. In case of three-phase short circuit in a system, the power fed into the system is, in case of a three-phase short circuit in a system, the power fed into the system is, options are mostly reactive, mostly active, both, none. So this is going to be mostly active. Why? Because when the short circuit occurs in the alternator will have a winding. Okay, that winding will be in nature of inductance. When a short circuit here, the load will be mostly inductive load. Okay, so that's it friends. If you like this video, please make a comment and share with your friends. Thank you. Have a nice day.